This video is over properties of logs. Now, the properties of logs, there's 8 properties. I split these up into 2 groups. The first group is kind of a more logical. You should know these by heart, and they kind of make sense. So, automatically make sense when you see them. So log base b equals 0. Okay, so if you have a base b, log base b of 1, it's automatically 0, because if you convert this over to an exponent, b to the 0 power equals 1. So it's a no-brainer. Like, we had a property of exponents where you have a 0 for the exponent, well, it's always 1. So this kind of goes by that property of exponents. The next one is if you have log base b of b, you will get 1, because we have a property of exponents that say b to the first power is b. Log base b of bx equals x. The reason being is if we convert this over to exponents, base b come over to x equals that b to the x power. And then we will have b to the log bx, that equals x2. That's because if we convert this over to a log, so if we go log base b, switch over to x, come back and get our exponent, we get the same thing, and this is the exponent part. Okay, so on this side, if you see any of these, whether it doesn't even matter what numbers you put in for b's, that will be the outcome. Okay, now the second set of properties. This is the product property. So if we have log base b m times n, we can actually split that up so that we can take log base m plus log base n. So with multiplying products or taking products, you can add. So multiplication and addition go hand in hand because we increase our value. So if you have log base b m divided by n, you can take log base m minus log base n. And then we have what's called the power rule. That was called the quotient rule because we have the quotient product rule. Now we have the power property. So if we have log base b m to the p power, we can rewrite that so that p is a coefficient of log base b m. And these properties they surprise me. It's just so crazy. It's magic to me sometimes. And then if we have log base b x equals log base b y, as long as the bases are the same, then x equals y. Okay, we can drop the logs. And reverse. So if we have x equals y, we can add the logs to both sides. So these will help you with solving for your logarithmic equations, which we will see in a later video. This video will focus on expanding logs and condensing logs. So we're going to expand logs. So log base b 4xz. So this is a product, 4 times x times z. So we can take log base b of 4 plus log base b of x plus log base b of z. Log base 4 square root x over 64. So this is log base 4 of square root x minus log 4 base 4 64. Now we can convert these into power. So log base 4, this is x to the 1/2 power, minus log base 4. 64 can convert into 4/3. Well, now we can use this property here. So this will reduce down to 3. And then this one, we can use our power rule to make that power into a coefficient. So that will be it. So sometimes when you have values, you can reduce way down to a single number. So log base b, y to the 3rd, square root x over z to the 3rd. So this will be log base b, y, and instead of cube root, I'm going to go x to the 1/3 power, because I'm going to convert that anyway, minus log base b, z to the 3rd. Now I'm going to break these two up. Log base b, y, plus log base b, x to the 1/3, minus, since I haven't done, or since I can't expand this by the product rule or quotient rule, I can use the power rule to bring that 3 out as a coefficient. And then to finalize this, I need to take that power and make that into a coefficient. Okay, so that's how to expand. So in some cases when you solve for logs, you may have to expand to solve. In other cases, in most cases that you will see in the college algebra course, we will have to do some condensing. Because when you condense your logs, when you condense the logs so that you have one log equaling a value, you can turn that into an exponent, an exponential equation to solve. So let's go log base b, x plus 2 minus log base b, y. Okay, so this is not part of a product property because it's not a single log x and a single log 2. So this is simply log base b, x plus 2 over y. And then let's see here, we can do 4 log base b, x plus 1/3 log base b, z. So we can turn this into a power, turn the other one into a power, and I don't know why I put a equal sign. Then this can actually be cube root z. Since we are adding, so we can turn that into a product. And we're done. Okay. So when we're solving these, sometimes we will have to condense, sometimes we have to expand. It just depends on what we have and what we feel like we need to do. -3 log base bx minus 2 log base y plus 1/2 log base bz. Okay, so there's a lot of things going on. What I'm going to do, since we have double negatives here, I'm going to rearrange this so that this log base bz is in front. Because we can't have double subtraction because we cannot have a triple decker fraction. So what we're going to do is actually take this and I'm going to go ahead and use the power property on this, but we're going to factor out a negative. And while I do that, I'm going to turn these into powers using my power property. And this one I should have done too. So now we have a product. So here I'm going to go ahead and turn that into This would be z to the 1/2 power. Well, that's the same thing as square root z. Minus, I'm going to convert this into one product. Now we have one single subtraction where we can stack the first log with the second log. And we're done. So that one needed a little more TLC. Again, we have two negative values or two subtractions. We cannot have a triple layer, so we can actually factor out a negative so that we have a product inside that parentheses, combine that, and then we have one fraction. So that will conclude this video.